afternoon, everybody, and thank you for joining this live conference organized by Valvoil and Dieci. Today we will talk about ALS, Adaptive Loss Sensing System, and its application on a Dieci Agriplus GD42.7 Telehandler. My name is Davide Mestorini. I am a Research and Development Manager at Valvoil Hydraulic Components, and I'm very glad to introduce Mr. Enrico Ognibene, Technical Director from Dieci. Good afternoon, Enrico. And I'm also pleased to introduce Francesco De Martino, Product Engineer in Research and Development in Valvoil.
Good afternoon,
Francesco. Let me first of all to thank the organization of Eima Digital and Federunacoma for giving the industry this interesting opportunity. We are all facing a very difficult moment where it is very difficult for the companies to share, present, discuss, and confrontating about the innovation. We know how much for innovation it is important to have this discussion process, and so we think that this opportunity to work on a web base is a very important and valuable solution that has been given. So it was very important to confirm the date of the Eima exhibition and to give continuity to this very important and international event. Today we will talk about an innovation in the hydraulic field that can bring some augmented functionality to the machinery and some improvement into the efficiency. This ALS system was conceived in Valvoil Research and Development, but was developed with the help and the support also of Dieci. So Enrico, the collaboration between Valvoil and Dieci is something that is going on since a very long time. Is that correct?
Yes, I confirm. The collaboration between Dieci and Valvoil had already begun before 1997, when Fratelli Dieci became Dieci. Dieci has been installing Valvoil components on their machines for many years with success and customer satisfaction. The two companies are part of engineering sector with a high level of expertise in hydraulic and mechatronics, with that development thanks to the agricultural mechanization since the last century in Emilia. Furthermore, both companies are dedicated to product development with particular attention to the innovation opportunities in the research for continuous improvement.
Yes, I think we have also some slides that we can show, and we can go a little more in detail explaining what is Dieci today.
Yes, Dieci was born in 1962. In 1983, designed and developed the first telehandlers. In 1997, Fratelli Dieci becomes Dieci, a group of industrialists with dedicated of experiences in various Emilian manufacturing sectors buys out the company and relaunch the business mainly on machinery. In 2007, new facilities inaugurated. We can see the picture. In 2008, Dieci decided to manufacture the first vehicle designed specifically for agricultural application. And the two main ranges for agricultural application, Agriplus and Agritech, became on the market. Today, the facility of Dieci reaching surface of 120,000 square meters, of which 40,000 covered. Dieci is represented in 70 countries around the world with 440 dealers and 3 branches. The production of machinery of Dieci in 2019 reached 2,800 machinery, and the turnover reached 163 million euros.
Yeah, and we know from direct experience how much Dieci is investing in innovation and always trying to get improvement in the machinery evolution. I will briefly explain you the context where the ALS solution was born. The ALS solution was conceived in Valvoil. Valvoil research and development. Valvoil is a company that is investing a lot in research and development, and the research and development department is strictly collaborating together with our test department. The test department of Valvoil is probably one of the most advanced hydraulic laboratory that we have in Europe, and there is a possibility to develop the complete product and also testing on the machine. The research and development of Valvoil is very focused on the environmental issue. We are always trying to find a better solution with a higher efficiency, and we are mainly focusing on two different lines of research. The first is the energy recovery, but we will not talk today about this point. The second point, the second line of research is the combination of components and trying to find the correct, the ideal matching of different components in order to maximize the efficiency on the machine. It is this is the way where Valvoil is investing and try to find also the answer and providing always a better solution for the market and also helping our customer in finding a solution for the challenges that are coming from the markets itself. We know that the machinery market is getting more and more difficult due to the regulation and the standards that are coming, and so there is a very need. We are strongly believing that there is a bigger space to improve the efficiency of the hydraulic circuit. Can you tell us a little more about the context of the machinery development?
Yes, the stage 5 compliant diesel engine are the last frontier in terms of emission limits. In addition to seeking and instinct the engine pollution emission limit, machine manufacturers such as Dieci are pushed towards a search for vehicle efficiency in all contexts of use. The advanced electronic vehicle control management system allow to integrate the different systems contained in the machine together with the diesel engine, including the hydraulic system. This is very important in the thermal management phases of the exhaust treatment system during the machine work to ensure high comfort and control to the operator.
Yeah, and Enrico, you highlighted very well how it is important to match the mechanic and the electronics in order to find a good solution for the efficiency of machinery. And Francesco, you are a mechatronic engineer, so nobody better than you knows how much it is important to match these two domains together today.
Yes, Davide. We know that the integration of mechanics and electronics can allow to explore new possibilities and features in the hydraulic field. Valvoil believes in this technological progress, and thanks to the electronic component, it's possible to provide the new operating mode for the operator on the machine in order to improve the operator experience. So thanks to this software, it's possible to customize and shape some movimentation, some movement on the machine. And this is possible thanks to this software and the experience of the electronic Valvoil department with the 20 years of experience and with a wide range of products starting from the handle and joystick to for the movement of the hydraulic component until the HU, sensor and software to monitor the parameters in stake.
Okay, a very big challenge. I think we can go a little deeper into the system and trying to understand how the ALS system works. We have a presentation where we can show you the detail. So we will start this presentation. Okay, the ALS system is perfectly matching together with the flow sharing valves. It matches actually with whatever flow sharing valve available on the market, but of course it has been optimized and works in a perfectly combination together with the valve oil flow sharing valves. The valve oil flow sharing valves are normally split in two big families, the DPX families and the EX families, that are approaching the world of different machinery with the two slightly different technologies. The ALS devices is available in a manifold solution that you can see at the center of the slide, or it can also be available integrated into the inlet cover of a complete valve block. In this case, you can see the integration into a DPX 100, being the DPX 100 one of the most diffused and best-seller valves from valve oil. So we go directly to the point, to the problem. When you have an hydraulic valve, a valve block connected to a variable pump, you are always paying a certain dissipation given by the controller of the pump. In order to realize a perfect controllability of the system, you always need to provide a pressure that is higher than the pressure that is actually required by the user, by the load. Also, if you work with a fixed pump, of course, this kind of system is more economical, most cost-effective, but also much more inefficient comparing to the variable system. In this case as well, when you are using loss sensing and flow sharing valve, you are paying a dissipation through the inlet compensator spool that is always providing an additional pressure drop that is functional to the controllability and the controllability of the load. So when we go to analyze the power situation, we can see that if the machine actually, the actuator actually need a certain level of power that is represented in blue, every time you have to add an additional power that is completely going in dissipation and so into it in the system that is represented by the orange area. If you consider that in a normal cycle, an average pressure, working pressure could be maybe 100 bar, this standby margin is normally representing 20, 25, sometimes even 30 bar, so it can represent much more, even more than 20% of energy dissipation into the system. So the target and the aim of the ALS system is exactly to introduce a new variable into the system and having the possibility to modulate and modify this pressure margin according to the working condition in order to optimize the system and finding the best efficiency condition to work. This is a representation of the complete system where you can recognize the variable displacement pump, the valve block that is including the ALS device, an electronic joystick, an ECU controlling and giving the brain to the whole system, and one actuator. When you operate the joystick through the ECU, you displace the spool of the main valve and you are feeding the actuator. The actuator can send the pressure information to the valve through the LS line. Normally, this LS line is transferred directly without any change to the pump, but in case of the ALS, it is modulated by the ALS itself and modified into the LSC signal, so that the pump can provide a pressure that is related not to the real loss sensing, but to the modified loss sensing signal LSC. So if you want to check how it works in a diagram, here you can see that the joystick is giving information to the ECU. The ECU is communicated to the valve is collecting the real loss sensing from the load, but then this loss sensing is modulated through the ALS system, thanks to the information coming, to the input coming from the ECU. And this LSC is delivered to the pump. The pump will add its natural standby, but the pressure P that is resulting into the system is actually modified and resulting in a different pressure drop across the spool. Here this animation is showing the variable standby that you actually have on the spool of the valve, and so you are conditioning the speed and the control characteristics. The heart of the ALS system is a simple hardware, simple hydraulic hardware that is mainly represented by a coping spool based on a 4-signal solution. And this coping spool is conditioned by 2 pressure-reducing valves. The first pressure reducing valve is deputy to increase the loss sensing, the LSC signal, and therefore to increase the standby, and this is giving an additional performance to the machine, while the second electro valves is deputy to reduce the LSC, therefore reducing the standby, and giving more controllability and more energy saving possibility. During the development, we had the opportunity to release a patent that has been already approved. We thank the organization of Eima we have the honor to have received the award for both innovation and sustainability for this project. And it is also worth to notice that this project was developed also in collaboration with the TASC project. The TASC project is a project that has been financed by the European community, is involving the most important laboratories and the university in Emilia-Romagna, and Valvoil is participating as an industrial partner. Okay, during the development of the ALS, we went through 3 different phases. The first phase was the simulation that we made through monodimensional software in order to check and analyze what are the benefits, the possible benefit of the solution. Then we went into an experimental phase where we tested the complete system on our test bench. Here we also have an output from our test bench. From this diagram, the most technical of you can see that we have a modulation in purple and green of the 2 electro valves, and this modulation is resulting in a modification of the LSC. As you can see, the natural loss sensing is in red, but the modified loss sensing, LSC, is in blue. So we start with a reduced loss sensing, and then at the end of the stroke, we reach an increased loss sensing. This allows to change the standby across the valve from 1 bar up to 30 bar, shaping and modifying the delivery curve, the delivery flow onto the actuator. Then we have a third phase, and the third phase is the application of the system on a real machine to test the benefit and understanding what is the real result on a real machine. And here is coming the collaboration with Dieci. And so, Enrico, can you tell us why you choose this kind of machine and which are the characteristics of this machine?
Davide, we choose the Agriplus. That is one of our most important machines for agricultural market. Agriplus is in 2 models, 42.7, 4.2 ton lift capacity in 7 meters, and 30.9, that is 4 ton lift capacity at 9 meters. Agriplus is a high-performance telehandler that we developed and studied for professional use for customer that needs high performance on telehandlers. The Agriplus includes the new cabin developed together with Giugiaro Design, where we introduce many improvements focused to the comfort of the operator. It's a wide cabin with precious materials, soundproof materials, with an exclusive hydraulic suspension system. On the Agriplus, we tried to introduce a total visibility with a panoramic view, with wide windows, and with a fine study of ergonomy to give to the operator the maximum comfort. Every command, every control is in the right position, easy to be reached. In the Agriplus, we introduce a high technology with an advanced electronic management, and by a single control unit, we can manage all the functions included on the machine, integrated with the engine diesel. With this high technology, we give a high performance machine with a high performance engine, 114 kilowatts, stage 5, with an electronic integrated control and a low emission. This integrated electronic system management system performs also a very strong and fast transmission with a cruise control in the cabin that can manage 4 different drive modes. And combined with these drive modes, we can add also the management of ALS.
Okay, thank you. Very interesting. If we go a little deeper inside the real hydraulic heart of this machine, we can summarize which are the main components that are taking part into the ALS system.
Yes, the ecosystem ALS is composed by valve oil DPX. The DPX family is a family of post-compensated load sensing flow sharing section valves. And there are 3 different sizes of DPX, the DPX 50, 100 and 160. These 3, the difference between these sizes is for the workflow port, and the 3 sizes have the same max pressure inlet up to 300 bar. The second component for the ALS ecosystem is the valve oil joystick. This joystick can be in 2 different versions. An analog version, the AJV, with an optional redundant signal, a CJV with a redundant signal, but in a CAN bus version. And in order to have an ergonomic design, it's possible to use the valve oil MTH handle. This handle has a capacitive sensor that can detect the operator presence. But the really heart of the ALS system is the ACU valve oil. In particular, the CHAD 1200. This ACU is, with this ACU, is possible to control 12 sections of section valves, and with the 24 input, it's possible with the 24 input that can acquire the digital frequency and analog signal. And there are also 2 sensor supply output.
Yep. And then the software.
And then the software, finally. With the PHC Studio, the proprietary valve oil software, it's possible to program the ACU with one of the programming languages cited by the EAC standard. The WVST is a proprietary software of valve oil, and with this software it's possible to monitor the working parameter in stake. So it's possible to say that for custom application we use the PHC Studio, but for standard application it's possible to use WVST. In particular, it's now the ALS software moment, and the ALS is programmed with an ASFG language, a standard function chart, and with this software it's possible to obtain all the modes of the ALS. In particular, there are transition and actions that command the different modes of the ALS system. In fact, with the transitions it's possible to exit or enter from different actions. So when a transition is verified, this means that the operator won't change the operating mode from the actual one. And the actions contains the instruction to for the operating mode that the operator has chosen.
Okay, great. And so which are the functions?
Yes, the ALS have two type of activation. Desired activation by the operator or automatic activation by the software. For example, this is a security when the machine is on, and an automatic activation can be the power limitation, for example. but the desired activation by the operator, the basis function of the ALS system, can be the boost, for example, or the precision. In particular, with the boost, it's possible to increase the flow rate to the actuation in order to have greater machine speed and productivity with an increase of standby. And the opposite side, there is the precision. With the precision mode, it's possible to have greater machine control and sensitivity because we have a reduced standby and flow rate. But the most important function in this case is the custom. This is a function that is a combination of the two previous modes. In fact, with the map that correlates the angle of joystick and standby, it's possible to obtain a custom curve with a particular application, and this is tuned for some particular application on the machine, for example.
Yeah. So we can shape exactly the delivery curve to the actuator, customizing and also making it more comfortable.
Yes, for example, in the initial part of the curve, it's possible to obtain a precision. So for a movement that requires bigger machine control, it's possible to obtain at the first part a precision. But when a movement is ended, it's now the time to go, and the boost condition is activated.
Okay.
But on the machine, Enrico, how it's possible to activate the ALS system?
Yes, we integrated the ALS activation system, integrating two buttons on the grip of the joystick, the green button and the red one. And acting on these two buttons, the operator can ask standby reduction or standby increasing. If we push on the green button, the standby is reduced and the movement slows down. Mm-hmm. If we push the red button on the grip, the standby is increased and the movement speed up. Yep. In this slide, we can see a typical diagram where the flow rate to the distributor compared to the stroke of the spool of the distributor, and we can see that on a standard machine, for example, the standby can be around 17-18 bars. With the green button, we can lower the standby until 6 bar, and we can reduce the flow rate from 120 liters, for example, to 70 liters. And this means to reduce the speed of the movement, also if the stroke and the angle of the joystick doesn't change.
So without losing the resolution of the control?
Yes, and the main benefit of this is the better sensibility and better control for the operator.
Okay.
The same way, we can increase the standby. For example, if you want to increase the speed of the movement, we can push the red button and to go from, for example, 120 liters to 140. For certain application, when the user of the machine is confident and needs speed, with the red button we can get it.
Okay. And these are not the only possible on-demand function of the ALS system. For example, there is also, and this is probably one of the most complicated on the software point of view, where there is more software behind, the possibility to look for the maximum efficiency target. It means that the system, by reading some parameters on the machine and having inside the complete mapping of the spool, of the characteristic of the directional control valve, can make some advanced evaluation in order to find the best efficiency condition to realize a specific flow. So actually, in this situation, the joystick electronically is setting the expected flow by the user. And and the system decides by itself under which condition to reach that specific flow. We are using some mapping similar to the diagram that you can see in this moment. It's a typical map where we have on the x-axis the standby pressure, so the margin, standby margin, and on the y-axis the spool displacement, so means the passage area, the metering passage area. The curve that you can see are some isoflow curves, so it means that we can reach a specific flow for different combination of standby and spool position. A normal system will work across this dotted line, so there is a fixed standby, but the ALS system can try to reach a specific flow through another path and reaching the flow in a different condition, minimizing the standby. Of course, there must be a mapping that is deciding when it is worse, when it is not worse. Sometimes there's a compromise to be found, but there is a very huge possibility to increase the efficiency of the machine.
Yeah, with the adaptive algorithm, it's possible to reach this result.
Yes, let's say it's an adaptive algorithm.
Exactly.
Another typical additional automatic, in this case, it's not the on-demand function, but it is an automatic function, is the power limitation. When the system can collect the system pressure, the flow rate, the engine RPM, it can automatically evaluate the power requested by the operator, and it can compare this power to the power limit given by the ICE engine. And in that case, if we are reaching the maximum allowable power, the system will automatically reduce the standby, having a benefit in terms of pressure, but also and mainly having a benefit in terms of reduced flow, so that the machine is kept under a certain limit of power and it doesn't stall. Another typical application is, for example, the possibility to use the dead man sensor, the capacitive sensor, for the detection of the presence of the operator into the grip in order to activate or deactivate the standby. When the auxiliary function and the boom is not used, there is no reason to keep the standby at a high level, and so we can drop it down in order to have additional efficiency. So I think, Enrico, we can have a general summarizing, understanding exactly which are what we can see actually on the machine as a benefit, summing all together this functionality.
Yes, we speak about efficiency, and the ALS can help us to get efficiency, because if we reduce the standby when it's not necessary to use the boom, for example, on machine traveling phases, we can reduce the hydraulic pressure drops, improving the efficiency in general and reducing consumption. If in opposite, increase the standby only when it is required, with small hydraulic components, we can achieve higher performance only when it's necessary and only when the operator asks for it. The results that we found during the development are that we considered some ideal work cycles of the Agriplus with the implemented ALS system. And by simulation performed by Valvoil and Dieci technical team, we found on the Agriplus a drop energy dispersion values of about -28% during combined operation with boom and transmission, and up to -45% during vehicle movement only by transmission. These numbers can result on average fuel reduction of -4%.
-4%.
The efficiency is not the only benefit that we can get. We can consider also a reliability of the machine equipped with the ALS, because if we reduce the standby when it's not necessary for the machine operation, we can reduce the stress of the components because we reduce the maximum pressure, and this extends the average life of the components. We can improve also the productivity, because with the automatic functions, if we reduce the standby, we reduce the movement, and we improve the sensibility of the control. And this reduce also the errors and the mistakes that the operator can get. And this maintaining the same joystick stroke and better sensibility of the control. If we increase the standby, for example, to speed up the movement, expert users can get the best performance and increase the speed of the movement when are needed. Mm-hmm. If we combine also the automatic function of the ALS with the anti-tipping device, we can reduce the standby when the machine is near the tipping limit. And in this condition, when we are at the limit, we can lower dynamic loads and the stress and improve the safety.
Yeah, so very important step for the safety. And we also have to notice and remind that the system is inherent, is automatically fail-safe, because in case of fail of the electronic, if you are missing the piloting to the electro valves, it will simply copy exactly the loss sensing system, and so it will we will get exactly a standard loss sensing system without affecting the controllability of the machine. So it is inherent safe.
We can speak also about the versatility of the system, because
that's interesting.
Yes, we think that Telehandlers is one of the most flexible machinery for agricultural application, because it's a multi-purpose machine that changes the functionality, changing the interchangeable equipment. And we can adapt the standby to the interchangeable equipment that is connected to the machine. In this way, we can optimize the speed of the machine movements compared to the attachment. For example, with a main basket, the machine must be slowly than with a bucket or a shovel. And modifying the standby, we can get high resolution on the control and low speed. Also, the flexibility, it's a big benefit, because the standby can be managed manually and automatically by integrated software function in the vehicle control management. And this can guarantee optimal performance in every conditions. The benefits are not related only on the machine, but as producers of machine, we can consider the benefit also across the range of our machines, because with standard components, with one hardware, we can set up different system, and in quick and easy way, we can set up the same components in different machines that requires different standby. In this way, we can optimize also the hydraulic system for each machine.
Yeah, so same hardware, and then dedicated parameterization according to the specific need of every single machine. I will just add another point that is also interesting. The components of the ALS system are so simple. Actually, they only requires a dedicated manifold and an electronic joystick and ECU, that they can also be introduced into an existing machine. So we can also talk about machine already working in the market, and it is possible to make an upgrade of the machine and bring it to new life. To new level of efficiency. That can be interesting, can result as an interesting solution also for the aftermarket. For the aftermarket. Okay, so we have this final slide where we are summarizing all the points that we have discussed about. This is what we are testing today on the machine and confirming after our original simulation. These are all the benefits that the system can provide. And I think we conclude this, this presentation and the technical presentation of the product. We leave you with the video, the official video that is summarizing all the concept, all the ideas. And I have to inform you that in the next days there will be several opportunities in the virtual spaces of the Eima Digital, where Valvoil and Dieci will have some technical people also available to answer your question and to give you more detail about the system. Of course, you can also get in touch with Valvoil and Dieci through the traditional means,
traditional method.
website, a normal way of communication. We thank you a lot for the attention. Thank you and bye.
Thank you.
Goodbye.
Goodbye.
Bye.
Sustainable development in agriculture is one of the key factors for the future of our planet. Therefore, the continuous technological evolution of agricultural machinery towards more efficient and environmentally friendly solutions is essential. Hydraulic systems for the operation of agricultural machinery are playing a very important role in this development process. In fact, digitization enables solutions that provide great opportunities for energy efficiency, facilitating compliance with the stringent regulations regarding internal combustion engines, and providing greater autonomy for the new hybrid and electric drive technologies. The context. A typical cause of the loss of efficiency of a hydraulic system is the standby pressure differential. The hydraulic pump, in order to ensure the control of movements, generates a pressure constantly higher than the actually required one. It is defined as standby margin and constitutes an energy dissipation. The adaptive load sensing solution. Adaptive load sensing is the answer to this problem. The innovative system has been developed at Valvoil Research and Development Department and tested in collaboration with Dieci, a leading company in the telehandler sector. This development is also part of the TASC, Smart and Clean Agricultural Tractors project, co-financed by the European funds of the Emilia-Romagna region and including the participation of international partners and the main regional universities and research laboratories. Adaptive load sensing is patent pending. How it works. The system consists of a directional control valve, an electronic joystick, and an electronic control unit. The heart of adaptive load sensing is represented by an electro-hydraulic device fitted to the directional control valve, which allows to dynamically modulate the standby margin in order to minimize energy consumption. In traditional load sensing systems, the standby pressure differential may lead to a dissipation, loss of up to 20% of the system energy. And, since it is preset, it limits the performance of the engine at the top of its operating range. Adaptive load sensing would bring the dissipation levels to around 10%, therefore improving the engine performance across all duty levels on the engine performance characteristic curves. The system consists of an electronic control unit that collects information from the operator and from the machine sensors. The electronic control unit operates the adaptive load sensing device, allowing to raise or lower the load sensing hydraulic signal and consequently varying the pressure differential to dynamically adjust it to the efficiency and functionality requirements. The system is completely managed by a modular and customizable software developed by Valvoil using the PHC Studio proprietary tool. Operational functions. The software basically includes several automatic functions, selection of the maximum efficiency conditions, power limitation management to ensure full exploitation of the engine characteristic curve, automatic reduction of standby pressure in the inactivity phases of the auxiliary functions. Moreover, additional functions are available to optimize control and can be selected by the operator using the joystick controls. The precision function reduces the standby value, allowing to improve the accuracy and sensitivity of the operation. The boost function temporarily increases the standby value for higher speed and productivity without installing larger pumps. Safety. Unlike previous variable standby systems with electronic devices on the pump, adaptive load sensing operates directly on the load sensing hydraulic signal, thus avoiding the complexity associated with signal digitization. The adaptive load sensing system can also provide two independent controls to increase and reduce the signal so that, in the event of faults, the system works with the natural standby of the pump, keeping full functionality. These combined aspects make adaptive load sensing an extremely robust and safe device. Stability. The smart management of the standby pressure differential, combined with the operation of the directional valve, allow to optimize the stability of the machine for a more comfortable use. Retrofit. Since adaptive load sensing consists of a few additional elements, it can be easily interfaced with traditional hydraulic components and retrofitted on machines already on the market, bringing greater efficiency and productivity. Test results. Tests carried out on Dieci Agriplus GD 42.7 Telehandler, equipped with two fixed displacement pumps, showed the following reductions in terms of standby energy loss: minus 28% during boom operations, minus 45% during traveling operations. It results in a global energy save up to 5%, depending on the considered operating cycle. Considering also the increased functionality and the better exploitation of the endothermic engine, the level of innovation introduced by adaptive load sensing is even more evident. Energy efficiency, productivity, controllability, customization, safety, stability, retrofit is all about valve oil adaptive load sensing system.